So welcome Level 2 NCEA physicists, continuing on with Level 2 Mechanics External and looking at the graphing of motion. Okay, so you should now, or by now, have an idea of the different shapes associated with different types of motion. Okay, so you should know the shapes of the distance time, velocity time, and acceleration time graphs when you have either constant displacement, constant positive and negative velocity, positive acceleration when you've got speeding up, so the acceleration is speeding up, positive acceleration when it's slowing down, and also negative acceleration when it's speeding up, the negative acceleration is speeding up, and when negative acceleration is slowing down. So you need to be familiar with what these graphs actually look like when you're answering your questions. So in terms of acceleration, is it slowing up, or the object slowing down, or speeding up? When the acceleration is in the same direction as the velocity, the acceleration is seen to be speeding up. The object is speeding up. You've got foot on the gas, and those are the graphs that you should see in terms of positive acceleration and negative acceleration. For both displacement, velocity, and acceleration. And when the acceleration is in the opposite direction as the velocity, the object would be slowing down, or is slowing down, and you've got the foot on the brake, okay, you've got that stop sign, and you should know the associated distance or displacement time, velocity time, and acceleration time graphs for those particular cases, both in the positive acceleration when it's slowing down, and negative acceleration when it is slowing down. So we'll look at some examples of getting information from a velocity time graph. So what is the velocity at 4 seconds? Okay, that comes straight from the graph. You just plot it or take it from the graph. It is going to be 4 meters per second, straight from the graph. What is the acceleration from 1 second to negative 4 seconds? That's going to be the gradient. It's going to be 1 meters per second. And what is the displacement after 4 seconds? That's going to be the area of the graph. Half base times height, so 8 meters. In terms of this graph, a velocity time graph, because now you've got this negative gradient, the velocity is now going to be negative 4 meters per second. Okay, so again, that's straight from the graph. The gradient will now be a negative gradient, negative 1 meters per second. And now the displacement, because again it's negative, is negative 8 meters, okay? Because it's displacement, not distance, so it's going to have a direction as well as a magnitude. In terms of this velocity time graph, what's the velocity after 4 seconds? Again, that's straight from the graph, 4 meters per second. The acceleration, again, is going to be the gradient, so it's going to be change in velocity over change in time, so 4 minus 2 divided by 4. Be careful with that, okay, because these are going to be a y-intercept. So it's going to be 0.5 meters per second. And in terms of displacement, the area under the graph will incorporate not only the triangle shape, but the rectangle shape, so it's going to be 12 meters per second, because it's going to be 8 plus 4. That's the displacement. And finally, information from this velocity time graph is going to be what is the velocity after 3 seconds. Okay, that's straight from the graph, so minus 2 meters per second. What's the acceleration from 1 to 3 seconds? That's a little bit more tricky. Okay, so again, that's going to be the gradient from 1 to 3, so 2 minus 2 divided by 2, so it's going to be minus 2 meters per second, and the area under the graph is going to be 2 meters, basically 1 plus 1. Okay. 3 seconds, sorry. So it's going to be 2 plus 1 minus 1. So that's going to be 2 meters. Apologies. So in terms of graphs, in summary, I guess, the displacement versus time graph is going to give you the slope, which will be the velocity. The velocity time graph will give you the slope, which again, this will be acceleration, and the velocity versus time graph, the area under the graph, is going to give you the displacement.